In this video, we're going to learn about polynomial functions. These are functions that have smooth curves, and they fall into the form where you have p of x is equal to a sub n, x to the n, a sub n minus 1, x to the n minus 1, and any other terms that you may have, followed by a sub 1 to the x and a sub 0. We have some special features from the way that we write this polynomial. First of all, a sub n is called the leading coefficient. And the leading coefficient will help you to determine n behavior. And we'll talk about that in our next video. The value of n that we have here is the degree of our polynomial. This whole thing we have here is called the leading term. And together with the degree, the leading term, and the leading coefficient, that tells us a lot about what happens to our polynomial as we go to negative infinity and positive infinity. A sub 1x is known as the linear term, and a sub 0 is known as the constant term. These values that we have here, this n minus 1, and 1, you won't actually see those when you write the polynomial. These are just identifiers to say that a sub n is different from a sub n minus 1. A couple of examples of polynomials that you can have. As we've been looking at the last section, you can look at a quadratic. Now, a quadratic is where your leading term is 2. As we looked at last chapter, all of your quadratics are going to form parabolas, whether they are up or whether they are down. Another type of polynomial is called a cubic. And a cubic has the feature such that it will start at one side and then do some stuff and go to the other side. So we either start at negative infinity and end up going towards positive infinity, or it will start at negative infinity and end down to start at positive infinity and go down to negative infinity. We also have a quartic. And a quartic can look like this, or it can look like this, or any variation between. It may actually look like a parabola as well. It will only have this wiggle if there's some other terms that go along with it. Now, these are just the leading terms that we have for our polynomials. We can have any of our other terms. For example, an example of quadratic would be this. An example of a cubic would be this. Quartic. And so on and so forth. But what's really important is the degree of the polynomial and any leading coefficients that we may have. As I said before, these polynomials will have smooth curves. You won't have any bounces or bumps, or you won't have any hard points, I should say. So you won't have anything that looks like this. You won't have anything that looks like this. And you won't have anything that looks like this. This is more like a square root function. This is when you have something to a fractional power, and this could be an absolute type function as well. These are not polynomials. Okay?